He has been the member of Governing Council, Board of Studies, and Board of Examiners, etc., for many institutes of repute. He has been associated with CA, CMA, and CS coaching institutes as faculty at all levels of the course. At present, he is a freelance adjunct faculty, practicing advocate, company secretary, and agri entrepreneur involved in organic farming, and a qualified insolvency professional of Insolvency and Bankruptcy Board of India. We are it's a pleasure to us to have Dr. Kesava Rao in our forum. Over to you, sir. And one small announcement, around 8:30, we will be taking a small break of 2-3 minutes for announcements. Over to you.
Thank you, Shilpa. Good morning, ladies and gentlemen. A small glitch in my internet connectivity, so I am getting connected through my mobile phone, so I may not be able to switch on the video because of the bandwidth problems. Kindly bear with me. But briefly, we'll see each other for a minute or so, and then I will switch it off.
Do you have a PPT also? Would you like?
Yeah, I'll be sharing that. So today's task that is being given to me by Shilpa and Mr. Subbarao is that we will orient ourselves to the simulation. What is it? How we'll be doing it in a regular aspect. I think that 2 hours will be sufficient for us to get accustomed to that. Probably in next session, we will be looking at it from the point of view of valuation as to how to apply this. And maybe 1 or 2 models like binomial model or Black-Scholes model, how we'll be able to apply them in valuation is a basic idea. And for another 2 hours, I'll be treating you as my students, and then accordingly, I'll be going ahead with it. Please bear with me. And thank you very much, Shilpa, for your introduction. Shall we start? Or do we need to wait for some more time for other people to join?
No problem. We can start.
We can start, right?
Because the recording is going on. So
okay. So more or less, I think, or I assume that people are almost 40 plus. Now, why I'm asking this question is there's a purpose behind it. For us, when we hear the word, or heard the word rather, simulator, it was basically relating to space research and astronauts. And we were all surprised that there will be an artificial environment that will be created and people will be getting trained into that. So I always give this example to my students in the regular classroom also. And you will be able to appreciate or realize the fact that when we were small kids, we'll be waiting for summer. And summer means relatives will come. Once they come, out of their love and affection, they will give us a rupee or 2. Those days, rupee or 2 also is a big amount. And then we used to take that to the rented cycle shop fellow or bicycle shop fellow, bargain it, half an hour, 1 hour, something like that. And you don't know. Therefore, what will you do? You hold some other of your own age group, and the fellow will help you to hold the bicycle, and then we will start cycling it. That's how you would have remembered that, like many people would have fallen and cut whatnot. All those things is a common phenomenon. Now, when you interpolate that to the current situation wherein, when you are talking about a car or maybe a truck driving institute or something like that, they would have created the entire setup, whatever the driver has, to the trainer also. All these things are going to be little costly, but still they have done all those things because the very purpose is, if they commit a mistake, the damage is going to be higher. So as the damage quantity or the quantum of damage is going to be higher and higher, we got to be much more careful. That is where the simulation came into existence. To start with, it was relating to some kind of manufacturing activity and research activity way back in 1940s. And during the World War, people realized that all these techniques can be utilized even for a war phenomena. And later, business entities started using them for the business activities also. And that's how the techniques of operations research, popularly we call them as, everything came into the business activities also. I think at least few of you would have studied this particular concept, operations research, in your course, either in CA or CMA. CS, I doubt it was there, but I don't know whether you'll be able to recall that. So this is a brief introduction about our simulation, what we are going to learn. So as I told you, because of my bandwidth, I'll be switching off my video. Can you see the PPT? Can any one of you please?
Yes, sir, we can see, sir.
Thank you. Thank you.
You can go into slideshow mode. Yeah.
Yeah, it's already there on the slideshow. Is it not?
Yes, yes.
Okay. When we look at briefly about what is operations research of the World War II and the associated activities and all those things, this kind of a small definition has come into existence. It is the art of winning the war without actually fighting it. So what they have done during the war, they have identified the experts in different fields and put them into one particular room, and they said that give me solutions, only then you'll be able to come out alive. Right. And these people had to do a lot of research, and then they came out, and these are all were relating to the operations of the war. Therefore, the name operations research came into existence. And these people with little resources or scarce resources also could win the war. And that's how the business today is no way inferior to the real life war situation. And accordingly, this has come into existence. This definition, I will love it because it makes a lot of sense. It is the art of giving bad answers to the problems which otherwise have worse answers. That's the definition given by T.L. Sati. So by applying any one of these techniques, be it linear programming, transportation, networking, or anything, if we are under the impression that we are going to give the perfect solution, we are absolutely wrong, and we are only giving them some kind of an idea. And I'm pretty sure that in valuation also, we are going to do the same thing. Instead of having nothing in our hand, we will have some kind of data through which we will be able to operate and then come to a conclusion as to whatever we are doing is going to be somewhere close to the reality. Not necessary that it is going to be close to the reality. So when you talk about, either you take the examples of capital budgeting or investment analysis or valuation for that matter, the first step is that we will assume that everything is certain, and accordingly we will identify the values that are attached to that and apply them and come to a conclusion as to whether the decision what we are taking is right or wrong. That is how we start actually. But when you look at, I'm sorry, but when we look at the reality in life, it's absolutely not in our hands, not under our control. Therefore, what we have to do, we brought in probability, standard deviation, variance, all those things, and we depended on the likely values and then came to certain conclusions. And that was not enough to come to any conclusion. Therefore, we went to scenario analysis. So I need not tell you what a scenario is, where we will be identifying all the parameters that are attached to a situation, give a value, and then come to a conclusion as to what is the likelihood or the outcome, what is the likely outcome. And then for that again we will have probability, and then we will be having an expected value for that also. So that was not sufficient again. Therefore, people went to sensitivity analysis. So in the sensitivity analysis, what is that we are going to do? We are going to look at if for every variable there is going to be some kind of a range and the most likely value, keeping all other things constant, and I'll keep on changing one value, and then we will try to identify what is the likelihood and how is it sensitive, how sensitive the variable is to the outcome or the objective what we need to achieve. So that was the sensitivity analysis. Again, the manipulation was done by us, but unfortunately the variables are random. So what exactly we mean by random in this context is, we know what is the likelihood, what is the likely value, but we don't know what situation for that particular point in time that is going to happen. Whenever we talk about probability, we just give simple examples of coin and throwing die and things like that. We know that it is going to be either head or tails when we are going to throw a coin, but we don't know what is going to be the outcome. This is the basic mindset with which we'll be operating the probability. Now what we are doing in simulation, we will bring the probability, we will bring the randomness, and we will try to avoid it to avoid the bias to the maximum possible extent, and look at the maximum number of operations or the units, so that the probability of being correct is going to increase. Hope I am making sense to you all.
Yes, yes.
Yeah. So when we are talking about the supercomputers that have come into existence, our life has become much more comfortable. Otherwise, it was little difficult to apply this simulation, especially simulation. If I have to give you a simplest possible example of the recent phenomena, there was a cyclone which was supposed to hit the coast somewhere near Orissa, but all of a sudden it has changed its course of action, and we could understand that all these things, how they could come out with a solution is basically with the help of our simulation. So now you can understand the application of simulation from the simple demand supply problem to the highest level of predicting the environment in which we are operating. Therefore, we will not be able to look at it from the total problem point of view, but we'll only able to understand what is the logic behind it in today's session. So that is the purpose of the today's session.
So one second, some background noise is coming from your end. So you can be a little louder also.
Somebody's mic is on.
Actually, I'm muting everyone as and when some disturbance is coming.
Yeah, now it has gone. See,
Yes, sir. Now
somebody is.
Now it is very clear.
Yeah.
Thank you, sir. Go ahead.
Thank you. Now, when in our course of discussion, we'll be using this word model. So we'll just have a brief idea as to what is this model which we are talking about. In layman's language, if I have to tell you, model is the replica of the origin. Without hurting the feelings of majority of the people, the moment we talk about the word model, immediately we will get a visualization of some models walking on the ramp. I'm sorry if I'm using a wrong word, but that is the visualization which we are going to get when we are talking about model. So what is that they're doing here? If they are going to wear, or you and me are going to wear that particular kind of dress or jewelry, as the case maybe, we may look like that, but in fact, in reality, it will never happen, but still we'll be carried away by that, and then we'll be buying so many things. So that is not our concern here. So what is that we are going to do? We are going to talk about all the attributes of the original and bring that and create a replica of that, give treatment to some of the variables or change, modify, whatever it is, and then we will try to come to conclusion as to how it is happening. When we start with models, started with physical models, and then later they went on to the other things like more on mathematical models. So models, there are various types of models are there. Let us not go into the minute details of all those things, classification and all. But when we are talking about this model, our simulation is a symbolic model, a mathematical model. Please don't get confused by looking at the word mathematical model. It's a simple profit is equal to revenue minus cost. It is also a mathematical model too. It may go to any extent. So here we are going to use symbols to represent certain things, and then with the help of them, we'll be able to identify. And this simulation model, what we are talking about is more on descriptive, rarely to some extent, it is also predictive. It basically describes what is that particular model, what is that reality, and how we will be able to understand, and then we will come to conclusion about certain things. That's why rarely it is predictive also. And simulation is a dynamic model which assumes or understands that the situation in which we are operating cannot be static. It is going to change, and which is not in our hands. And this is a probabilistic model in the sense that the occurrence of the events that are going to be there are having some kind of probability of occurrence in future. Now let us look at simulation in general first, and then we will look at simulation with the help of Monte Carlo method. So simulation of a system or an organism or an organization is the operation of a model or a simulator, which is a representation of the system or organism. Now, why do we need this? It makes us, or it gives us an authority or a flexibility to manipulate, which is otherwise impossible. Suppose when you are taking a simple example, when you are talking about a blueprint of your own house, before constructing, we will have it so that if necessary, we can manipulate it. After constructing the house, we will not be able to do it. So that is the very purpose of doing it. Suppose if I have to get an idea whether a particular business is going to run profitably or not, the best way is that I have to learn it by doing it. But if I try to do that, there is a possibility that incurring lots of losses, and there is a possibility of a lot of time that is involved in that. So to overcome that, what we will try to do, we'll try to identify the variables, we'll try to create a model, we'll try to do some kind of manipulation of that. This value is going to be like this value is going to be like this, and then we will try to some conclusion. But the problem when you look at it, is it practically possible for us to bring in, incorporate each and every variable that is going to be there in a real life situation? Absolutely not. If that is possible, then you and me were not required. Even a computer would have given them the solution, and accordingly they would have decided upon on the basis of a software package or something like that. So give all the data and the software package will give the value, and that will be more authentic, and they need not worry about anything else. So that would have been the situation. So it actually gives us an opportunity, and each one of us, by virtue of our judgment or our ability or our skills, will give different values to them, and that becomes the base for taking any decision. So it's a process of designing a model of a real system and conducting the experiments with this model for the purpose of understanding the behavior for the set of limits imposed by the criteria and for the operation of the system. This is the definition given by a person by name Shannon. So in brief, what is that we were discussing is simulation imitates reality to represent reality. Again, I repeat, it cannot be reality as such, but it will make an attempt to represent the reality. And it gives us an opportunity to conduct the experiments and conclusion. Is a descriptive, not optimizing technique, in the sense that whatever which we are going, details which we are going to put in, on the basis of that, it is going to describe the situation for us. This requires a repetition of the experiment many times. Like if I can tell you that if you have to predict certain things very clearly, a simple demand supply problem also, unless you do about some billions of experiments, you will not be able to reach at least 60% of the reliability. All that can happen now because of the well-connected computer system, speed, everything is there. Now we'll be able to do that. So the next thing is simulation is used only when the problem under investigation is too complex to be treated by analytical models or by numerical optimization techniques. So I always give this example. I don't know how many of you have visited Madurai Meenakshi temple. And when you look at it, they have given a model. We go there whenever we get lost, we go to that particular place and see where we are, and then we'll be able to identify and go to a place where we need to reach. For that matter, even malls also, we have that particular kind of a facility now. They would have given you, you are here, and if you want something like that is been there. But that kind of situation will not be there when we are talking about our house. Because our house, at the most, what would have happened? A very simple, limited. So in the sense, we'll be able to see everything. You just go 5 steps, you'll reach the next room. But that is not possible in certain cases. So in simulation, a given system is copied. The variables and constant associated with it are manipulated in the artificial environment to examine the behavior of the system. And on the basis of that, we'll be able to come to certain conclusion. Let us not go into the minute details of it. Now let us see the steps. Let me tell you very categorically, these are the steps in any simulation process in general, not exactly relating to solving the problem of simulation. So the first step in simulation process is to identify the problem. I've just given a simple example because you're all matured enough to understand, so I need not go into the minute details. So any problem, like if you take a simple example, a newspaper vendor, the most important and complicated problem is that how many number of units he has to buy so that he'll be able to meet the requirement of the people without minimizing or wasting the newspaper. Because you know it very well, newspaper is such a thing where after afternoon, it is equal to a waste paper. 2, it can go to any level. So like that, if you look at various things, we'll be able to look at that there is something which we need to answer. And that's where the first step is identify the problem. The second step is to identify the decision variables. What is the objective and the decision rules? Now, decision variables are those variables which are not under our control, which are going to vary, and that variation will be random. Only then we'll be able to run a simulation. If they are going to move in a predicted manner, then you'll not be able to apply simulation. The variables shall be responsible to measure the performance of the system in terms of, here in this example, relating to the inventory. Next, we'll be constructing a numerical model. So numerical model, something like that. Let me give you a simple example. There is a bakery. It will be buying cakes from somebody. Assuming the cake's life is about 48 hours. First 24 hours, it will have full value. Next day, it will be sold at a lower value. Next day to that, it will be of no use. So the next question comes here is that how many units I should place an order or something like that. So what can we do is that we can do a simulation run and then come to a conclusion. So what are the variables here? There are two variables. One, the supply, if at all you want to meet it, or you can make it as a constant also. So the only variable that comes into existence now is the demand, which is not under our control. So for every different demand positions, what happens will be able to identify. Alternatively, if I am going to put X stock, X plus 1 stock, X plus 2 stock, something like that, what is going to be the outcome? This is what we call it as what if analysis. So we can do a full-fledged simulation run, or we can also do what if analysis. But for all these things, the number of units demanded multiplied with selling price will be the revenue. The number of units sold in the subsequent day for a loss. So the new selling price, supplied unit minus demanded units, or supplied units minus demanded units multiplied with the entire cost that has been incurred, and that will give you the profit. And that is a simple numerical model which we are talking about. The next one is that I'm not talking about solving the problem. Please remember, that's the reason why validating the model is required. So in validation of the model, what do? We just try to run it with certain number of experiments. We'll try to identify whether it is giving us the expected outcome or not. Once we feel that it is not giving that expected outcome, then we are going to change that model itself. And we will design the experiments, conduct the experiments, and then we will be running the simulation model. As I said, it will be run on a computer. And if you want the precise output, then we will be going to supercomputers also. And then we will examine the result, look at the reliability and correctness. If not, again, repeat the entire process. This is the steps in simulation process. I'll just suggest you that instead of me talking about these things, you can please go through it. And I'm 100% sure that with the level of maturity, you'll be able to understand these sentences very easily. So a straightforward, simple technique. So it's useful to analyze large, complex problems. The interactive method, because it enables us to make the changes in the inputs or in the model itself. The experiments are run on a model, but not on the system itself. Therefore, even if it is going to be wrong, nothing is going to happen. We're not going to lose anything. So limitations, at times it can be very costly and expensive. Trial and error technique produces different solutions, and the solutions obtained from the simulation may not be optimal. So it needs to be examined and analyzed for decision making. It only creates an alternative, but not an optimal solution by itself. Ultimately, it is you who is going to take the decision. Now comes the Monte Carlo method of simulation. So this method of simulation is being developed way back in 1940, von Neumann and Ullm. So this is actually developed in the field of nuclear physics, in the fusion, and those days they were trying to identify about the nuclear energy and things like that. If I give this example of nuclear energy and so on, now all of us will be able to understand very easily, because majority of us would have seen the Rocket Boys series. So we'll get some idea as to how they used to do it in a simulator and all those things. That was a physical simulator. So am I making sense, Shilpa, or fast, slow, whatever it is? Can you just give me a feedback so that?
It's super fine. Please go ahead.
All right. All right. So what is that we are going to do in Monte Carlo method of simulation? Is we are going to depend on random numbers. So random numbers are the numbers where we don't have any hold or any, I can say that if you are going to make manipulation to the numbers itself, then whatever we are going to do, the reliability of that will become a big, big problem. So random means it should be absolutely random. For my satisfaction, I'll just tell you how we will select the random numbers. If it is 0 to 99, the most primitive method is that we will write 0, 1, 2 up to 99, fold that, roll them and keep them in a bag, shuffle them properly and ask any one of them to pick up one. You would have seen, especially when you are playing Tombola, probably you would have applied this particular model of selecting the random number. So this is one primitive method of selecting the random numbers. And the most predominantly used method of random number when we are talking about in a regular phenomena is the Excel sheet. You have random number generator and that will only generate the random number and give it to you. So that is not a problem at all. Technically, we will be using about the random number tables that will be given at the end of any problem, whatever which we are talking about. Random number tables are readily available that we will be using majority of the occasions. So if you look at the random number tables, there will be 5 digits and under any circumstances, you will not be able to identify the relationship between first, second, third. If you are able to identify a relationship, then it will not be absolutely random numbers at all. So you will not be able to identify any kind of relationship between any random number under any circumstances. It will be absolutely random. Or there is something called pseudo-random numbers. Just for your information, I'll share this. So what we will do is that, suppose let us take a simple example. We need a 4-digit random number. So what we will do is that we will.
Sir, presently we are seeing your PPT. Are you showing us?
I'm not showing anything as such.
Okay.
I'm just explaining orally. You want me to show that how you'll be generating it?
Yeah, few of them could be curious to know.
Okay. Just a minute, please. When you're talking about pseudo-random numbers, we will select any seed. Can I ask any one of you to please tell me one number of 4 digits of your choice, preferably without having zeros in that?
1999.
1999. This will become seed 1. We are seeing it, right?
Yes.
I'll just make it big little so that it will become easier. So the person who has told, can you please square it for me?
Square.
Yeah, square of this particular number.
39
96 001.
996,001. So it is now 7 digits. What we will do is that we will add 0 this side. So you know it very well that will not make any difference. And this 4 digits of this 9960. So 9960 is the random number 1, and that itself will become seed number 2. Then again, what we will do, this 9960, we will square it.
99201600.
92. Sorry, I'm sorry.
9920
Okay, 9920
1600.
1600. I think I'll put 19 extra here. Now 2016 will become the next random number, that is random number 2, and that will become seed 3. So this is how we'll be able to generate random numbers. These are called pseudo random numbers.
Why did you added 0 in the seed 1 number?
Because we wanted 4-digit random numbers, and here there are only 7 digits. So we have to make it to the double to the seed. And in between 4 numbers we will take.
No, I didn't get that. 7 digits includes 4 digits, so 4 could have been taken
Yes.
out of.
Then when you are talking about 7 digits, what we need is in between 4. So exact 4 in between. So if you don't take this, assume that hypothetically this is not there. So what will you take? If you are taking 9960, fair enough, not an issue.
Hmm.
If you are not taking in between that, suppose if you are taking from this 9600, then the entire values will change.
But
So
that
only to
can
bring
be
uniformity to that calculation, we'll just say that add 1 0, make it 8 digit, and in between the 4 digits you take, so that it will become easier for you. That's all. Without adding 0 also you can take it. That's not an issue at all. Hope I'm making sense to you.
But is it just to make it easy, or there is some other reason also?
It's only to make it easy. That's all. Nothing specific
Okay,
as such.
okay. Got it.
Alternatively, what you have to do is last 2 digits you have to leave, the remaining 4 you have to take. So either of the ways it makes the same value as such. If you want 5 digits, then accordingly we will start with 5-digit seed, and then we will get 10 digits when you square it. If not, we will add 1 0 and make it 10 digits. In between 5 values, we will be selecting it. Would you like to see that also? Not required, right?
No, sir, not required.
Right.
But can you
Yeah.
explain what is this seed 1? I mean, what is this 1999?
Any number of your choice.
But in Monte Carlo, what this number would say?
That we will come to that.
Okay.
This 9960 is a random number, first random number, and the second random number is 2016.
Got it, sir. Got it.
And then it will continue like that. It will go to any value. And if you try to identify the relationship between 9960, 2016, and the subsequent number under any circumstances, there will not be any relationship. That's why they are called random numbers. Hope you got it.
Yeah, yeah.
Right. Thank you. At least somebody interacting, it makes my life more comfortable, and we teachers love that somebody should talk.
Yeah, we are able to very well understand this and follow it fully. So I think till now nicely articulated.
Thank you, Mr. Ramesh. So what is that we are going to do is with the help of random numbers. Everything runs because of the random numbers. So at this point in time, let me give you a simple clarity that depending upon the probability and the size of activities which we want, we are going to decide these random numbers. For example, let us take a simple example of a demand supply situation. And there is a 5-digit random numbers for us. So first 2 digits of that, we will use it for the first variable. Last 2 digits of that, we will be using it for the next variable. There are random numbers which are having about 6 digits also. And if 3 variables are there, first 2 digits will be used for first set, first variable. Second 2 digits, that is third and fourth digit, will be used for the second variable, and next one will be used for the third variable. And people say that when you do this kind of thing, you get more reliability than taking different random numbers in that particular order. Got it now? Once we solve a simple problem, probably that will make more sense to you than
Yes, sir.
looking at it. Right. What is that we are going to do in a Monte Carlo method of simulation? First, we will try to understand the problem and convert that into a mathematical model with decision variables incorporated into that. And then we'll identify the probability distribution. Now, when we are talking about probability, all of us know it very well that it is the likelihood of occurrence of something. So how do we identify the likelihood of occurrence of something? You would have studied 3 methods of quantifying the probability. One is the classical method. The best example for classical method is that when we throw a die, any number between 1 to 6 will come, and the probability of occurrence for all of them is 1 by 6. And this is the classical method of identifying the probability that is attached to a particular thing. We always give this example. Unless you are the descendant of Shakuni of Mahabharata, you will be always having the probability of 1 by 6. Otherwise, it will be 100% probability, because you know the story, right? The person has the capacity of getting the number whatever he wants, and that's how he ruins everybody. So that jokes apart. Then what will we do? We will identify the cumulative probability and then assign tag numbers to that. Now, please understand what is that we are trying to do. Demand is there. Demand is going to be certain value. And now that we have the probability that is attached to that, we'll be able to say that, let me give you a simplest possible example. A bakery, 25 units of cakes he will be able to sell. The probability of occurrence is 40.4. That means what? If you take a sample of 100 days, out of that 40 days, he will be able to sell this 25 cakes. Now, the demand is random. So to identify that, we will give that certain numbers, and that we call them as tag numbers. So for example, if I have given 0 to 39 as the tag numbers to this particular situation, when I use the random numbers, suppose if I get 25, I'll come to a conclusion that that time the demand for the cakes is that particular number which we were talking about. So that is the reason why, with the help of the cumulative probability distribution, we will assign the tag numbers.
So what you're saying is that suppose the demand for cakes can be anything on any day between
Right.
0 and 39 cakes, right? And then
Yeah.
based on that,
No,
the
it is not
probability of
0 and 39. The number of cakes may be, let us take a simple example, 25, 26, 27, 28, 29, something like that.
right.
So this 20, for example, 27 cakes. So when you're talking about 27 cakes, for about 40 days in a sample, you are getting a demand for 29 cakes.
Mm-hmm.
So you will assign 40 numbers to that particular situation. When you pick up a random number, any number you get, you assume that this is 29 cakes demand for a particular day, for the particular trial run. Am I making sense to you?
Is it, sir, that you have taken a sample of 100 days, and in sample of 100 days, you found that 25 cakes were sold for 40 days, something?
That's how we'll be able to identify the relative frequency approach to identify the probability, right?
Okay, so as per your example,
No, let me complete this probability calculation part of it, then I'll come to this example so that it will become a little easier for you.
okay.
So probability, when we are trying to identify, first method is that we will apply the classical theory. where we will see the favorable outcomes divided by the total possible outcomes, and then we will come to example of probability. Example that I can give you is that when you toss the coin, head or tails, two possibilities are there. Therefore, 1/2 is the probability for head, 1/2 is the probability for the tail. This is the classical approach. Now, if I'll not take any one of your example, I'll take my own example. If you go by the classical probability, what is the possibility that you and me will be alive tomorrow? If you go by that, you have to tell 50% possibility, right? Being alive is favorable. Being alive or dead, these are the two possible outcomes. So that according to classical approach, you have to say that it is 50%. Agreed, right?
Yeah.
This part is
That's
clear.
agreed. Starting point is 50%. Yes.
Right. Now, if a person is in coma for about 20 years, 25 years or something like that, if you ask for her, or her, I'm using the word because you know that there was a nurse from Bombay who was in coma for about 28 years. Remember that example? I mean, that news.
Yes, yes.
Yeah. So if you ask for her also, the probability is 50%. We are all hale and healthy and sitting here. For us also 50%. For a person who was there in 28 years coma also 50%. So absolutely logical. So then they came out with relative frequency approach. So anybody, if you don't mind telling your age, ladies will not, but gentlemen can.
37.
Oh, good. Shital is 37-year-old and I am 52-year-old. If I have to take insurance policy, both of us, if they are taking insurance policy about, let us say 50 lakh rupees, who will pay more premium?
You.
I'll be paying more premium. Why? Because it is assumed that the probability of occurrence of death in my age group is more compared to that of Shital. And this is what exactly we call them as actuarial sciences, right? And that's how they'll be preparing the tables, models of insurance policies and so on. So what is that they have done? In this age group, on an average, how many people are going to die in a year? They have a table. And on the basis of that, they will come out with a probability of occurrence of death in each age group, and accordingly, the premium will be charged. So this is the relative frequency approach. And this is what we are going to apply. Now, bringing that, let me not confuse you. I'll only take two cases. 20 cakes, 30 cakes. These are the two possibilities. You have taken a data of 200 days, out of which 80 days you observe that 20 cakes were there. 120 days you observe that 30 cakes demand was there. Now the probability of occurrence is 0.4 and 0.6. Up to that part is very, very clear.
Yes.
Now, when I take 100 days, 200 days is the data which I have observed. And on the basis of that, I come to a conclusion of a probability. On any day, if I take, there is 40% probability that the number of cakes will be 20. 60% probability that the number of cakes demanded will be 30. Agreed?
Yes.
Now that 20 and 30 is not in my hands. For that, I am going to use random number as a proxy. So what will I do? I'll put from 0 to 39 belonging to the category of 20 cakes. 40 to 99, I put them into the category of 30 cakes. When I pick a random number, if the number is 25, I presume that that trial or that day's demand is 20 units. If I get 90, then I presume that it is 30. Like that, we will identify the value for the variable which is random and unknown. To do that, we are going to assign the tag numbers for each and every category. Hope you got it now.
So this probability you are finding out, the answer basically you are trying to find out is for the question, what will be demand on X day?
Correct.
Given this data.
Yeah, in any experiment today, or in any trial run, what is going to be the demand, because that is the random variable in this example, what we were thinking about.
Okay, got it.
Not necessary that there will be only one variable. There can be more number of variables also. And in fact, in reality, real life situation, more number of variables will be there.
Sir, good morning.
Yeah.
So this, is it possible to show some of your samples with the Excel numbers so that it will be little easy? Then what are numbers? You have some sample format?
Yeah, we are doing it. It's only first explanation I'm giving for the steps involved in that. So we are going to solve problems.
Introduction of the terminology.
Yeah, what are the steps that are involved? And then once we have the clarity of the steps, then we'll be able to understand the problem. And in the process only, I want you to have some idea, not necessarily that you'll be understanding everything in full. So once we solve a simple problem, probably I think with your level of maturity, you'll be able to understand it very comfortably. Correct? So we will generate the random numbers or take it from the table as the case may be. But today's situation, we will not go to table or anything like that. We will just use random number generator formula from Excel, and then accordingly we are going to get it. Immediately we'll be able to apply that. In fact, Excel has made our life much more comfortable. But at this point in time, straight away I'll not be going to Excel. We'll only doing it on a Word document so that you'll be able to do it and understand the philosophy or the methodology behind it. Once you understand the methodology, you will be able to apply it anyway, whatever you want. Shall we continue?
Yes, sir, please.
So we will conduct the simulation experiment and we will repeat step 4. That is, bring the random number, apply it, and then identify the values. And then we will review it. If necessary, we will try to make certain changes. And then we will decide the course of action. So let me briefly tell you what is that we are going to do. First, we will read the problem that is being given to us or which we are facing. Identify the decision variables, and on the basis of that, we will develop a mathematical model. This is the first step. 2, either we will have the probability in hand, or we will take a sample and with the help of that, we will identify the probability using relative frequency approach. Then we will assign tag numbers to each and every random variable. Go to the random table, select a random number. Looking at the random number, the value for the random variable. And in the meantime, we would have prepared a worksheet. If I have to give you a simple example, selling price and cost, number of units. So this number of units, what you are purchasing, if I keep it as a constant, let us take a simple example that 100 rupees is the cost price at which we are buying. And every day you are buying 20, let us say 30 units. So your cost is known constant, that is 3,000. Now, when you are talking about demand, when you are buying 30 units, not necessary that you will be able to buy or you will be able to sell all the 30 units. So some days it may be 25, or sometimes the demand may go up to 30 to 35 also. So how do we deal with it? So when you are buying 30 units and selling only 25 units at a rate of, let us say 100, what is the profit you are making? Like that, we'll be able to identify that. We'll be creating a worksheet depending upon our requirement and convenience. And then we will fill up the data, and then we will come to a conclusion as to what should be the course of action. This is how we'll be applying Monte Carlo method. So as I said, in the very beginning, if I directly go to valuation related examples, it will become little uncomfortable. I don't say difficult, but uncomfortable for comprehend. Therefore, we have taken a conscious decision that today we will talk about something like basic demand, supply, maybe to some extent capital budgeting if time permits. And then we will look at the other things little later. So this is the introduction to the method and also to simulation in general. Now we are going to take up the problems, and in between, Madam Shilpa was telling that she has to make certain announcement. Once you
Yeah,
are done with it, then we will take up the problems.
yeah. First, I would like to, request all the members to share with your friends about the Bangalore Valuers Association. Am I audible?
Sir,
My
again,
voice
the
clear?
background noise started from your mic.
Just give me 1 second. Yeah, am I audible now? Is it clear?
Yeah.
Yeah, first I would like to request all the members, to share with your friends who are registered valuers to come join our association, to help us in our pursuit of knowledge sharing. Sir, can you just, allow me to share my screen? I am of the view that, financial modeling, knowledge of financial modeling is important. Rather, to understand the flaws of a financial modeling submitted to us is also important. So I would like to run a poll wherein, I'm requesting your interest for a 20-hour workshop, which is about financial modeling. This financial modeling, I understand, is a course, given by ICAI. And one of the faculty in this is Mr. Nitesh Bhuta, who is a chartered accountant. So I feel that, few of us could be interested in this financial modeling course, but I would like to know the numbers. This is going to be a paid session, and it's a 20-hour program. So most of it is required for me to pay to the speaker, whatever charges, and other nominal charges only we'll be adding from our association side. Mostly it is for the speakers. And your interest will also help me to schedule whether it will be on a, say, 4th Saturday or a 2nd Saturday. And most of you are interested, there will be no normal session. But then very few interest I get, these sessions will continue, and whoever are interested, sessions will be conducted separately. In this context, would you like to know any more questions on this? I will share I will share the course content as of now given by the speaker. Yeah, please, questions, please.
Shilpa, can you explain what is financial modeling also to the members first?
Yeah, while you can see my screen, this is about, is some background noise coming in, or am I audible and clear?
Now you are clear, Shilpa.
Yeah, it could be about, the data points, what we take. It could be projections also. It could be the business model as such, starting from the business model, then the data points, then the historical analysis, and how is the revenue built up made, how is the cost built up made. I am personally of the view that, I may be a best valuer, but the model given to me has certain flaws. If I'm able to correct it, that will always make my valuation, a better, rather than I just take it blindly, whatever they give, and then give a random risk factor to it. So this is my assumption. Few of you could differ. So all of this revenue built up, cost built up, working capital schedule, asset schedule. So few of them could have, we may not get a complete asset schedule from the, our company. We may have to, see whether they have done it correctly or not. Mostly I see all these modeling problems in a relatively smaller company with a not so, a promoter is not so well averse with the modeling. This is how we face these problems, and we cannot just refuse an inquiry, which comes from not so, a person who doesn't have a proper financial modeling. We may also think of, a person coming for an inquiry for valuation, and he absolutely doesn't have any modeling. So we may refer to one of us after this course, that, okay, one of us friend will do financial modeling and another friend can do valuation. All this discussion is that, we are not supposed to do financial modeling for the company for which we are valued. I'm coming from that background. And this course, debt schedule, projected financial statements, and this is just a continuation, income approach, and but this is the course content given by the speaker. We can little bit modify to suit our requirements.
Can I say my suggestions?
Yes, please.
See, a couple of points here. We are all qualified, experienced. from the institute side, there are a lot of restrictions from a CPU credit hours, and we are also from BVA as a credit hours. Added to that, one is a knowledge, second thing is the time spent for each provision. Especially there are some members who are IPs and other company secretary, chart accountants. So it's become big hectic even though we would like to run. My sincere suggestion is, why can't we make that session is only as a part of a year? We are having every Saturdays, no? And the part 1, part 2, part 3.
That is a paid session. No? We have to pay to the speaker.
We can find out that. No, what I'm saying is, my point is, we're all, this is a networking knowledge improvement session. If that person is not interested, we can find out there are a few professors who would like to passionately.
I want to do it as a workshop, 20-hour workshop. If I break it 2 hours, that it's morely designed like presently designed like a workshop. If I give 2 hours, like how I am doing, it will be simple introduction, but complete thing will not happen.
What I suggest is, I think at the theme, all our members are there. We can make course content design. There are some expert speakers are there who are willing to come and share. This is my thought. You can discuss. I'm interested for the topic, but this concerns are too many. One is in terms of time, and the other one is cost also. Yeah, I think
basically this is a replica of ICI crash course on because few of our members may not be CA, who will not be able to take up that crash course, like cost accountants or company secretary. I was keeping them in mind and following little bit, ICI kind of a crash course model, but relatively at an affordable price. That was my context, while design. Okay, all points are well taken.
What's the schedule you are planning? I mean, this cannot be a marathon 20 hours program, right? So how do you plan it?
I was planning 3 to 4 hour sessions, Saturday, Sundays.
Okay, thank you.
How do you differentiate basic and expert level in this?
We will be requesting the speaker. Basic will be like, more into actually building the process. Expert will be more of, the flaws involved or the corrections which we have to make. I am sure most of you will be interested in. I will just launch the poll results. Yeah. So most of it, 11, I can see 11 people are interested. So maybe, for 11 people, I may not be able to replace the BVA sessions. So whoever are interested, please ping me separately. I will create a separate WhatsApp group for that. And then the discussion will continue. I just wanted to know the basic interest. 11 out of 23 is like only half. So I can't replace the BVA sessions for 11 people.
What would be the cost, ma'am?
All depends upon how many people are coming. So maybe somewhere around 4 to 5K could be, mostly the cost will be paid to the speaker and nominal, charges BVA will be collecting for,
it's very reasonable, I believe. Yeah.
Yeah. Mostly because, all of us are taking up this course together. I can't say replacing ICI crash course, but something to match. That is why I have approached the same faculty who has designed the ICI crash course on financial modeling. And this could be a little bit flexible because, the speaker, we are also paying the speaker. So I have the flexibility to ask what I want. So I will be creating a separate WhatsApp group and the discussion will continue there. Thanks a lot. I am sorry for the, interrupting the speaker's flow. Please go ahead, sir.
Good effort, Shilpa. I have already attended his lectures.
Mr. Nitesh Bhutta, is it?
He's an excellent one, actually.
Yeah, thank you so much for supporting me.
He's an excellent person.
Yes, thanks.
It was really a boon to attend his courses. So I request all the other people also to attend, actually. So get benefited. Thank you.
Thank you so much. Actually, this speaker also, I was actually, searching for the person who actually teaches ICI members on financial modeling. That is why I have chosen this speaker. Okay. Kesava sir, please go ahead. 1 minute. I'm trying to, is my share? Yeah, I have stopped sharing.
Okay. Now, may I request the members to have a calculator with them? some calculations we'll be doing because it will become a little easier for us to get involved and then do it. Can anybody tell me that you are able to see this Word document?
Yes, sir.
All right, thank you. I'll be using this particular kind of an example in my regular classroom here. I'll not be able to use that, but I'll just tell you out of interest how we'll be telling the students to motivate them to bring their calculator. Say that any problem-oriented subject or class is something like your own marriage, and whatever that is supposed to be done should be done by you only, others cannot do on your behalf. So it is always better to have a calculator. At least some 3-4 of you are ready to support me, right?
Yes, sir. Yes.
All right, thank you. So please go through this briefly. It is the simplest possible problem which we will start with because we should get the hands-on of the particular method. A tourist car operator finds that during the past few months, the car's use has varied so much that the cost of maintaining the car varied considerably. During the past 200 days, the demand for the car fluctuated as given below. So the number of trips per week, 0 to 5, and the frequency has been given. And quickly we can look at 16 plus 24, 40, 71, 31, 70, 200. This is the frequency that is being given. Using the random numbers, simulate the demand for a 10-week period. Now, let me make it very clear to you that with the 10-week period, we will not be able to achieve anything. But we'll only be knowing, in this class, we'll only be knowing that as to how to apply that particular mechanism. And so that once we know that, then we'll be able to apply it anywhere where we want to apply that. Now, I have a solution readily with me. Now, shall we solve it, or will you be happy to see and then understand?
We'll see and understand, sir.
That's fair enough, right? Because you're all mature enough, so let me not waste time on that. So this is the first step. 16, 24, 30, 60, 40, 30 is about 200. So we have calculated the relative frequency on the basis of that. Relative frequency in simple is that the number of observations that are favorable divided by the total number of observations. So 16 out of 200 and things like this. And the probability is 0.08 to 0.15. And please have the clarity that this should be equal to 1. Only then we'll be able to go ahead with this particular problem. Now, the cumulative probability we have calculated. This is basically to identify the random numbers very comfortably. Now, if you look at this, after the decimal, there are 2 digits. Therefore, we are going to go with 2-digit random numbers. Starting from 0 to 99, 0 also has included as one of the random numbers, because it is not that we are going to look at the values of it. It's only an identifier. Here 0 does not have anything. It's only an identifier. Therefore, 0 to 7. So that makes 8 observations falling into this particular category. From there, next 12, we will put it into the second category. From there, next 15. From there, next 30. From there, next 20. And from there, next 15. One simple logic is that the first tag number will start from 0. And the last number will be invariably, 00 is not required actually, invariably 99. Is this part clear to you?
Yes, sir.
This is clear.
So when you look at the calculation part of it to make our life simple. The first value is 0, starting value. For the next one, starting value will be the cumulative frequency value of that 8. The next one will be 20, 35, 65, and 85. And the last value will be 99. So 85 minus 1, 65 minus 1, 35 minus 1, 20 minus 1, 8 minus 1. That's how you'll be doing it. This is the shortcut. But the logic behind is that you have 100 values ranging from 0 to 99, of which 8 you are allotting here, 12, 15, 30, 20, 15, like that. We are allotting to each one of that. Now, let me give you a simple example. Once we pick up a random number, the random number has become, let us say, 32. So 32 is landing in this random number interval. Therefore, we assume that for that week, the number of trips are 2. Should I give another example?
Yes.
All right. So let us take a simple example. The second random number when you pick up, let us say it is 72. So 72 is belonging to this interval, 65 to 84. So when that 72 comes, we presume that the number of trips per week is 4. So what is that we are doing? With the help of the tag numbers, what we have identified, we are identifying the demand, which is random variable. And then we are coming to a conclusion about that. Why? The number of trips is absolutely not under your control. Please understand that whatever that is under our control, we cannot call them as random, which is absolutely not under our control. And the value does not depend. Suppose, let us take a simple example. If for this particular week, if the number of trips are 3, that will not have any impact on the subsequent week number of trips in the subsequent week. And in turn, that will not have any impact on the subsequent week. So that's why it is called as random. Got
So
it?
is it, sir, that it is always dependent on the historical data?
Which one?
Finding out the random number interval will always be dependent on historical data. Historical
Yes,
data
yes.
is
It is on the basis of the historical data. We will identify the probability. On the basis of that, we will assign them. So the next question that should you come to your mind is that you are telling that 8 numbers I have to allocate. So any 8 I can allocate, 1, 5, 10, 12, something like that. You can allocate. There is no problem at all. But this gives us this gives us a kind of a clarity and easy approach. That's the reason why this is the way it is being followed. Got it now?
You mean to say is that in random number interval, we could give where 0 to 07 it is, we can give it as 9 to 27 also.
You can give any number, but that will not become the real random because you have manipulated it. Here what happens is it is in the order, the variable. In the same order, we have been assigning the tag numbers. Technically speaking, if you are looking at the model as such, see here the number is 0.08. That means 8 values are falling in this particular category out of 100. So you can take 100 values. In that 100 values, any 8 you can give, but that will not be most appropriate.
Got it, sir. Got it. So you are establishing a relationship between random number interval and cumulative probability.
Yeah, this is actually not a random number. You may get confused. It's a tag numbers. So tagging them. This particular is this tag. So this particular 8 to 19, any value comes, then we will take it as 1 trip per week, like that. So now let us see I'll just mask it for you for the time being. Yeah. See, the first week, these are all the random numbers which are there given in the problem. So I didn't show that to you for the beginning. Now the number is 82. Now, can you tell me what is the number of trips per week? 4. 96.
5.
18. 18. 1. Again 96, which you know. 20.
2.
2. Including that number. 11.
1.
3.
0.
0. So what is that we have done? With the help of the random numbers, we are trying to ascertain the value for the random variable. This is how we have done it actually, which you have already told me. So 4, 5, 1, all that, and it has come to about 28.
Sir, how were the random numbers generated, sir?
Random numbers table is there, sir. Random number table is there that we will be using. But when you are talking about this, actually these problems were prepared for CMICA final class way back. So where we will be giving them the random numbers in the example itself.
So these random numbers can be generated by Excel also, correct? There's some method.
Yeah, absolutely. Once you generate the random numbers through Excel, you can as well give what if condition, and then that itself will take the value. We need not do all these things because we are doing it for the first time. I'm just showing you how we have to do it physically.
So random number generation is like basically taking out a lottery, is it?
Absolutely.
Oh, okay. Okay.
Lottery way you can take it, but the problem here, what happens is that the numbers are huge. Then it is practically not possible for us to operate every time the lottery and making it more and more what you call unbiased. Therefore, we take the random number table and then do it. And as far as the examination is concerned, we will only give the random numbers to make our life comfortable, because when different random numbers you are using, then I have to check every time.
Sir, for relative frequency, you mentioned the formula number of frequency in favor versus total number of observations.
Favorable divided by the total number of observations.
Yeah. So, can you elaborate on that, sir?
See here, sir, we have about 200 days data we have taken.
Okay, sir.
So this is total is 200 days data. Out of this 200, 16 is belonging to 0 category. So 16 times there were no trips for that particular person. So 16 out of 200, if it is for 1, how much? So that will become 0.08, and you know it very well that probability maximum, the total value of the probability is 1.
Okay, sir.
And on the basis of that, we have done this.
Okay, sir. Thank you, sir.
Thank you. So then we have to identify the average demand. So 2.8 cars per week.
Sir, one question, Natraj here.
Yes,
probably
sir.
I missed it.
Yeah.
Can you please go up? How did you arrive at not this next table?
Next table.
Random. How did you arrive at? Sorry, sir. Next table.
Okay.
Next table. How did you arrive at demand? 82 is a random number. How did you arrive at?
See, what happens is, like when you look at the random number table, the value is 82.
Yes.
This is been given, but assume that you are looking at that. In that example, what we were doing, suppose 9960 was the random number, right? First random number or something like that.
Right. Okay.
So 99, we will take it as a random number because only one variable is there. First 2 digits, we will take it as a random number. For 99, in which category is it falling? So 99 is falling between 85 to 99.
Correct.
Therefore, we presume for that particular week, the number of trips is 5.
Okay. Yeah. The corresponding one we have to take. Okay.
Corresponding value, we will assume that is the random value for that.
Okay, makes sense. Thanks.
Right. This is the simplest one. Now it is giving that average demand is 28 out of 10. So what is the conclusion? What is that we have to draw? The conclusion is that the person will come to a conclusion that if I keep 3 cars per week, that is more than sufficient. Now the next question that comes to our mind is that 4, 5 also is possible. He is ready to forego that. Why? Because keeping an extra car is going to cost him. So he doesn't mind, like up to 3 he can manage, and majority of the occasions it is going to be 3. Therefore, let me be happy with whatever the money which I am going to generate with it. So that's how we'll be drawing conclusions from this. Am I making sense to you?
Sir, it is not possible to draw a relationship between tag number and the demand always, correct?
No. Tag numbers are only to identify.
Yes.
Like let us take a simple example. When we are writing our examination, we'll be having a roll number, right?
Yes.
In that roll number, some particular digit may say that these are all people from Karnataka, these are all people from southern India, something like that. So that tag number is something like that. You are identifying them, they're from southern India, some particular state or something like that. And on the basis of that, looking at that value, we will be able to identify the value of the demand, which is variable. Now, the reason here is that demand is not in our control. We will not be able to define what should be the demand. Or you will not be able to hold a AK-47 and then go to the fellow that you have to buy or you have to go for a trip, which is absolutely in the hands of the other person. Which is in the hands of the other person is absolutely random. When it is random, you should have some parameter to identify that. That's the reason why we say that with this, suppose, for example, this 10 data values which you have taken, if you try to come to a conclusion that you are going to keep only 3 cars per week, you're absolutely wrong. The reliability of this will be 0.00 something. So you may run about 1 million or 1 billion to identify what is going to be the number of vehicles per week or number of trips per week. So that is the idea behind this. But this only gives us an idea how to do that. Hope I'm making sense to you.
Got it.
One small thing,
So
when you go for tag
Yes,
interval, no? Why is it stopping at the cumulative probability level? Why it can't be normal? Like normally we take a frequency table 0 to 10, 10 to 20, 20 to 30, like that,
So
So
because
any
the
specific,
first number is 0.
No, it's not equally distributed. No, it is based on the, like normally when we were doing math, statistics, no, that interval was like common.
That you are talking about
Tag number interval.
Tag number interval will not be there, class interval.
Yeah, it is stopping at cumulative probability number, right?
Yeah, got it. What your question? I got it.
Yeah,
It is
little
not
bit
the
down
class.
in the next table if you come.
I'll come to that. It is not the class. Please have the clarity. It is not the class.
Correct. Okay.
So it is,
yeah,
when
here.
you are talking class, you are going to identify the frequency for the class. Therefore, you make it as equiprobable. Like this is what you are talking about.
I'm talking about the last column, which starts
what
like
you are talking about when you are talking about equal values is this you are talking about.
Okay.
This is a discrete variable.
Okay.
Variables are 2 types. One is discrete variable, another is continuous variable. Discrete variable will take a full numerical value, whole number. Continuous values will take a range. So from the lower limit to the upper limit, we will decide what should be the number of classes, and accordingly we'll say 10 to 20, 20 to 30, 30 to 40. Is that what you are referring, if I'm understanding, Shilpa?
Yeah.
Right. So that is the class interval. That is the variable which we are talking about. But what we are doing it here is, please have the clarity, out of 200 days, 16 days, the demand is going to be 0. That means out of 100, 8 days the demand is going to be 0. Therefore, I will give 8 numbers to that particular category. This is the tag numbers. Now, when you're talking about 24, that means out of 200, when it is 24, out of 100, 12 days there will be, or 12 weeks, there will be a demand for 1 unit only. So therefore, I will assign 12 numbers after the first one to this particular category. This is the tag number calculation. Once I do that, because demand can be random, which is not under my control, therefore, to identify the demand, I'll pick up one random number and I'll get a particular random number and I'll compare it with the tag number and then identify what is going to be the demand for that. What should be the value for the random variable? Am I making sense?
Yeah, definitely. You can go ahead to the next one. I got it.
We have time up to 9:30, right?
We are available.
Sir, in the previous question,
let us look at,
sir,
yes, madam.
in the previous question, the problem was to know what was the demand.
Yeah. On an average, what will be the demand? That's all.
One sec, sir. Just using the random number, simulate the demand for 10-week period.
Correct.
And the solution you drawn was
10 random numbers we have taken.
10-week period, and these numbers you again, these are the random numbers which normally are given in the exam.
Correct.
Okay, and these are the demand. And
with the help of that, we identified the demand.
And solution was
28,
average
total
demand
28 for 10 weeks. So average it is 2.8 cars.
cars per week.
Yeah.
But it should be actually 2.8
trips rather.
Trips per week.
Yeah. 2.8 trips.
Okay.
Now that you have fair idea as to how to identify the tag numbers and then correlate them, we're a little complicated. Please look at this particular problem. Shall we?
Yeah, please go ahead. Are we waiting for something?
Then I just thought you should go through this so that I can continue. I think all of you have gone through it. Now the demand is varying from 0 to 50. Now in between numbers we are not considering. So probability is 0.01 and so on to 0.02. My sincere suggestion is that we should always keep the probability as total as 1 and the next random numbers is being given. Only for my general knowledge, we just do the cumulative probability here only. 0.01, 0.21, 0.36, 0.86, 0.98. Great. Now, can you tell me what are the tag numbers for this?
0.01.
0 to 1.
Zeros to be removed. The next two decimal to be considered.
Okay. So what is the tag number here?
0 to 0.2.
0 to 1.
Points will not come. Now you have tag numbers from 0 to 99.
0 to
19.
0 to 2.
0 to 1.
0 to 9.
0
It is
to
0 to 1.
0.00, sir.
0.
It is just 0. That's all.
0 to 9, actually.
No, it is
2 to
not.
20.
It's only one number because out of 100, only one will be favorable to this. So 0.
So there is no range in
0.01.
this.
Yeah, Rajesh, good. 0.01 means 1 day out of 100. So one number out of 100 numbers, that is 0. Including 0, I said. That's why 0 to 99. Is that making sense to you?
No, sir, please explain.
Are we talking about interval or only one range or one number?
In this case, range will not come because there is only one value, no?
Oh, okay.
See, probability 0.01 means 1 day out of 100 days. So one number out of 100 starting from 0 to 99, therefore only 0 will enter here.
Sir, in our earlier problem also only one number was there, no?
Correct, but that was 0.08. That means 8 values belong to that particular category.
Okay.
Here only one value belongs to this particular category.
Okay.
Got it now?
Yes.
Now the second.
It should be 1 to 20.
1 to 20, good. Next one.
21 to 35.
21 to 35.
You have learned the art already.
36 to 85.
We were aware of this, but then just got stuck in the first thing.
Yeah. That happens.
97.
97.
98 to 99.
98 and 99. Now tell me what is the
40. For 40, it will be 30. 30.
Agreed. Yeah.
10.
I think all of you are there, right?
40.
40.
Yes.
Yeah.
30.
Okay.
30. 30.
30.
20. 0.
10.
10.
Okay.
10.
10. And
Okay,
again 10.
That's all.
So essentially, probability will give us the range values, correct?
Correct.
Okay.
Because probability only tells us that when once we select a particular thing at random, what is the likelihood?
But I didn't
Now
understand
left to the chance.
zero part. In the tag number first one, 0, why should it not be 1? Because it has got 0.01.
Correct. Only one value belongs to that category. When you are talking about 2-digit random numbers, it is starting from 0. That is the first number.
Correct.
So first number is attached to this.
Okay, the first it's the opening interval.
Correct.
Sir, what I think is that in tag number assigning, we are looking at exclusive cumulative probability. If we make it inclusive, then it will be 0 to 1 and so on, and finally it will be 99 to 100.
This is the cumulative probability is only an indicator as to how to identify these values easily.
Okay.
Otherwise, what it is on the basis of the probability only. From 0 to 99, first value should be assigned to this. Next 20 values should be assigned to this. Next 15 values should be assigned to that. But to calculate will become easier. Our life will become easier, so that we'll do cumulative probability and then assign tag numbers comfortable.
Okay.
That is the purpose of it.
Okay, sir.
Right. Hope I'm making some sense and it is useful to you, getting something out of it.
This is now we are understanding, but for the purpose of our valuation, how this will be useful or how we can relate to it, that is something which we want to know.
Shall we directly go to that, or you want to see some more little complicated problems and then we will talk about that?
Is there something else also? Because you only know what would be that link.
These are all the simplest possible things. Now let me show you one more problem. This is about inventory calculation. This again, both supply and demand, if they are random, how do we do that? Shall we quickly see this? Let us not solve this, just quickly see this. So a small retailer deals in a perishable commodity. Demand and supply are the random variables. Past 500 days data is being given. And on the basis of that, using relative frequency approach, we will identify the frequency for supply. The one variable is supply. The next variable is demand. Now we have two variables coming into existence. So 40 by 500, 50 by 500, so 0.8, 0.1, and so on, will be able to identify the probability for supply. And then we will identify the tag numbers for supply separately. Could you see this?
Yes, so we got the probability and we got the ranges.
Yeah, tag numbers we have identified for both supply and demand.
Yes.
Then the random numbers are being given here. Before that, retailer buys the commodity at rupees 20 per kilogram, sells at rupees 30 per kilogram. On an average, he is making a profit of 10 rupees per kilogram. If any commodity remains at the end of the day, it has no resale value and is a dead loss.
Perishable.
Perishable. So moreover, the loss on any unsatisfied demand is rupees 8 per kilogram. Now let us look at the mathematical model that is involved here before we go to anything else. The ultimate objective is to make profit. Get it?
Yes.
How much profit is he going to make?
10
rupees
per kilogram.
Right. 10 rupees multiplied with everything.
Quantity X.
Which quantity we should take?
Closing balance.
Uh-huh.
No, sold. Sold.
Demand or supply, whichever is lower, right? Agreed.
Yeah, I mean, the
I
supply.
have ordered only for 30 units, but the demand was 40 units. So I'll not be able to sell 40 units.
Correct.
I'll just make it a little simple for you, because let me not confuse you, because after so many days, probably serious class you are attending. So we'll put conditions. Demand is greater than supply. Then what happens?
Into supply.
Only on the supplied units you'll be able to make profit of
10.
Right? Demand is less than the supply. Now the profit is 10 multiplied with
Demand.
Okay.
Minus that excess of supply, correct? Into.
We'll come to that. So slowly, first I wanted to have a clarity about this. I think this part is very, very clear, right?
Correct.
Yes, sir.
When demand is less than the supply, what happens? You are going to enter into a loss. How much loss? Supply minus demand is the number of units that are unsold. Agreed?
But sir, 20 rupees has to be.
Correct. I'm just telling you. Supply minus demand is the unsold units. Agreed, right?
Yes,
That 20 rupees is lost.
correct.
Is lost. Then demand minus supply. What is this? Unsatisfied demand. There was a demand for 40 units, whereas you had only 20 units. So 20 units you could not sell. When you could not sell, the unsatisfied demand is going to cost you 8 rupees.
Why will it cost 8
This is the
rupees? I
last
mean, if there is no, I'm not able to supply, I'm not incurring any loss, correct? It is only a notional loss. I mean,
right. Let us take a simple example, Mr. Sanjay. When you are going to a particular shop,
yes.
You ask for something and that is not available. Another 3-4 times you will not go there because you presume that it is not be available. So why to waste my time, and you go to some other place and get it done.
Right.
Correct.
So that if you can quantify, if it is going to be 8 rupees, that is the meaning of that.
Okay.
So unsatisfied demand, you are going to lose your customer either fully or tentatively. If that you can quantify, if it is going to be 8 rupees, how do we deal with it? This is the actual model. This is the mathematical model which we were talking about. So one place you can as well keep it as equal, because either there or here doesn't make any difference, because only 3 possibilities. One is equal, one is more, or another is less. More than that, there will not be any other possibility that comes into existence. Now we'll just only do one orally and then we will go to the remaining thing directly. Shall we? But of course, this is the formula, this is the logic. But what we will do is comfortably we will convert that into table. You would have always seen, even in capital budgeting also, NPV and all those things, though the formula is different, we will ultimately convert that into comfortably as a table and then we will do it. So here also we'll be doing the same thing, but this is the logic behind it. Now what they say is that first pair is for supply, second pair is for demand. Agreed? Now 31, if it is 31 supply, what is the supply value? That 31 is the random number for supply. So what is the supply value? 30, right? These are the tag numbers.
Okay.
So when 31 is the random number that is relating to supply, so 31 is falling in this category. Therefore, supply is presumed to be 30. Got it?
Yes.
Now, the second one, 18, is for the demand. So when you look at 18, the demand is falling into this category. Agreed?
Yes.
Supply is 30, demand is 20. So this is the relationship that comes into existence.
Yes.
So 10 multiplied with 20, 200. 30 minus 20, 10 multiplied with 20, 200. So you will enter into 0, neither profit nor loss.
Okay.
So this is the first run. Second run, again 63 we will take it for supply, 84 we will take it for demand, and then we will do it. And so on, we'll be continuing this particular experiment. So now let us quickly see the table, how we will be doing it. So random number, first set, 31. So 30 is the supply, 20 is the demand, cost is 600, revenue is also 600, there is no shortage, so the profit is 0. So the next one, when you look at it, 40 supply, 40 demand. Comfortably, he could sell all of them. So 40 multiplied with 10, 400 is the profit. But when you look at it, you just take it as cost as 800, revenue as 1200, and profit will be making. Got it, no?
Yes, sir.
This one is a very popular problem in CA exams also. Many times it has been repeated. So the company manufactures 30 units per product. The sale of these items depends upon demand, which has the following distribution: 27 to 32 with the associated probability distribution. So by now you know already how to assign the tag numbers, cumulative probability tag numbers. So let me not waste my time and your time also. The production cost and sale price are 40 and 50, again 10 rupees. Unsold product is to be disposed of at a loss of rupees 15 per unit. That means, what is the selling price for the unsold unit?
I mean, 15 is a cost to dispose, correct?
You are disposing it at a loss, 15 rupees. So what is the selling price of the unsold unit?
40 minus 50.
25. Agreed.
25.
So 25 will be the part. When you are selling them, you will be selling it at 25. So when you are selling on the same day, you get a revenue of 50. If you are selling on some other day, you'll be getting 25. And there's a penalty of rupees 5 per unit if the demand is not met. This part anyway we have seen already, and the random numbers has been given. The first one, 30 units stocking. Second one is 29 units stocking. So tag numbers will not change, whether it is 29 or 30 units. So these are the tag numbers. Briefly, just go through it.
Sir, the selling price is 50.
Correct.
And if it is not sold, then the loss will be 15. So will not that loss be calculated on selling price? It will be calculated on cost price only.
Naturally, no? You're buying it at 40, and when you are selling it at 25, only then the loss will become 15. If you go by your logic, 50 minus 15, it will become 35.
Right.
So if you are selling it at 35, your loss is only 5 rupees, no?
Yes.
Loss will not be calculated on the basis of the expected revenue. Loss will always be calculated on the basis of the cost incurred.
Correct.
So this tag numbers part is very clear. I don't think I need to explain it once again. Correct?
Sir, in that problem, it was 0.01, where
Correct.
we took 1 as a probability.
Correct. So here it is
Here it is
0.10.
0.10. That's why it is 0 to 9.
All right. Shall I continue?
Yes, sir.
All right. So with these random numbers, the simulated sales demand is being identified. Now the condition here is that 30 units you are going to keep as a stock. So number of units unsold, number of units in short. This is only to make our life comfortable. We are trying to make it into this particular category. And then accordingly, you will identify the profit or loss. This part is clear, right? $30 is stock. Therefore, 2 are unsold. So what will be the profit in this situation? Quickly, we'll just calculate by looking at the data. 40 multiplied with 30, 1,200 will be your cost. Agreed?
Yes, sir.
On 28 units, you are making a profit of 10, 280. On 2 units, you are losing 15. So 250 will be the effective profit.
Yes.
So like that, we'll be calculating. So 280 is the profit on actual sales, loss due to unsold. Then actually net part we didn't do it actually, but anyway, from here you'll be able to identify the value has become 2695. All right. Applying the same logic, if the company has to produce 29 units per day, then what happens? The values will change, but ultimately in this problem, the amount of money is going to be the same. The same 2695 will come. Very intelligently designed problem. Now, the decision point. Now tell me, if you are to be the COO of the company, what will be your decision? Will you produce 30 units or 29 units?
$30 units if both the situation is giving both the same profits.
So, you'll produce 30 units.
Yeah.
Okay. Mr. Sanjay, please don't mistake me. I'll just ask a simple question. I think Mr. Sanjay only was talking, right, that time?
Yeah.
Right. There is a race between a horse and a donkey. Which one will win?
Yes. Of course, the horse will win. Yeah.
The horse will win, right? So
Yeah.
this is the mistake, common mistake, which every one of us will be doing, thinking that race means immediately we will come to a conclusion that it is relating to running. It may be relating to carrying luggage.
Yeah.
So therefore, in absence of full information, we cannot come to any conclusion. Now for this, the typical answer should be, if the company is looking at expanding its market in the long run, then they should go for 30 because the company is aggressive. If the company is not ready to take any risk, then the company should go for 29 units because it is conservative. So that, like that, we have to give a qualified comment on this kind of situation. Hope I'm making sense to you.
Yes, sir.
Now, slowly come to, till now we have just seen that how this is going to be demand supply typical problem. Now let us look at this problem. Probably we may not be able to have time to solve this. I'll just share this document with you. You can give a try before we reassemble for the next one. So evaluating an investment opportunity that will enable them to introduce a new product, the market survey, demand, the number of units and the associated probability, cash flow after tax has already been given, likely investment, all these things have assumed to be random. Technically speaking, likely investment, we will not take this as a random thing because we know beforehand as to what is the quantum of investment which we are going to make. And they have made our life a little more comfortable or uncomfortable rather. Cost of capital of 9% has been given, and we have to identify CFAT, and then we have to identify how it is going to have an impact on the overall profitability of the business activity, and 3 sets of random numbers are being given. If it is been given like these 3 sets, first set we will take it for demand, next set for cash flow, next set for investment, and then we will apply them. This is in simple about the introductory part of simulation. Now, over to you, Shilpa. Now, before that, Shilpa comes into any doubts and any clarifications. I don't use the word doubt, but any clarification.
So there will be one more class for establishing a relationship of what we have now basic knowledge on simulation.
Yeah, with valuation, along with other models like binomial and Black-Scholes.
But this is normally used in valuation for option valuation, correct, no, sir?
We can use it anywhere. Even for business valuation also we can use it, provided we have the variables identified and the attached probabilities with them. Majority of the occasions, what happens is that we'll not be able to identify the probability to all the variables that are attached to it.
So, sir, will you take some example on option valuation?
Yeah, undoubtedly.
Okay.
We felt that without knowing the basics, without getting introduced to the topic, if we go to the advanced, we may not be able to get a complete understanding of the topic. That is why this session is more like an introduction thing. We'll be planning somewhere in July for next session on the same topic, mostly relevant to valuation.
Shilpa, we will plan in residential program also these sessions because it will take more time. We will see that also.
Oh, if it is possible, can't we plan it soon, like as soon as possible?
Yeah, we will connect to the speaker. We will see, the next slot is already like almost another speaker is decided.
I request Dr. Rao to take up as soon as possible, because this is something which requires a basic knowledge. And if we forego in due course, then again some introduction would be required.
Retention is a problem.
Yeah, with so many things going on in life.
Yeah, you're right. Absolutely right. So what we are thinking is that let this knowledge percolate to some extent into the minds of the people, and then we can take it up. And in the meantime, I will share these documents with you so that you can also have one hands-on. And last problem, deliberately I didn't solve it, so that you will do it on your own, and then you will get the doubts and clarifications. Yes, Shilpa madam.
Whether any participant would like to have any query, it could be on today's presentation or it could be on future financial modeling course, anything as such. And I also posted a CVA course, Certified Valuer Analyst. This designation is recognized worldwide as a valuer. So a person who has completed the CVA course and having acquired this CVA designation is eligible to issue valuation certificate in US and few other countries also. So last time we had planned for all, a small WhatsApp group was also created for the CVA course, but we couldn't actually take it up. So few of our group members, 1 or 2, have also taken it up. We found personally it's mostly of a basic valuation knowledge. Whoever is wants to have a basic valuation knowledge could be much benefited via this CVA course. Any doubts, please feel free to connect to me. Shall I go ahead and can we conclude the session, or any points or any queries?
No, I think it was good actually. We understood kind of how the random variable works, and yeah, long time. Statistics 12th standard, and now we are again revisiting it. Yeah.
On behalf of Bangalore Valuers Association,
In fact,
I would
one
like
second, Shilpa. In fact, majority of us who are afraid of problems and other things, we will actually move to CS. Yeah, sorry.
On behalf of Bangalore Valuers Association, I would like to thank Dr. Kesava for accepting our request and taking up this session. Sir, it was really helpful and benefiting to us. We are all remembering and recollecting all our statistics knowledge that we had read long back or for valuation course. It was really useful for us. We were all wondering, how this option valuation works or how this Monte Carlo simulation works. Now with the basic foundation you have laid for us, I hope we will be understanding the optional models. It could be Monte Carlo, it could be binomial, it could be, all these simulation models we'll be able to better understand. Thanks all. Have a happy weekend.
Okay,
Thank you.
I think we can.
Thank you, sir.
Thank you.
Thank you.
Have a great week ahead. Can I leave, Shilpa madam?
Yes, sir.
Thank you.
Yeah, please share the PPT and the
Sure,
Word file
I'll
what you have
share it.
made.